What's up, everyone? Welcome to episode 2 of Grasping Neurology, where we're going to be talking about the actual mechanisms of how we learn something, and in the hopes that by understanding it, you can better adapt to actually learning things you want to learn. And as you may have figured out by last week's video, the risk of learning, it actually may be even more important to attenuate, inhibit, and maybe make a right-handed turn around things you don't want to learn. Now, as we go through today's video, I'm going to be referencing a swordsmith making a sword. Not that I have any swordsmithing abilities at all, but I think we all have this generalized idea from movies and probably Lord of the Rings of a sword getting red hot and being hammered to be built differently and shaped differently, and then getting put into coolant and so on and so forth. So, if you haven't already seen the Introduction to Neurology course, the beginning of this may be a little awkward when we talk about neurons, but that being said, scroll on over, you already have the password. But we're starting with neuron-to-neuron communication, meaning we have a message of luminal intensity or enough electrochemical excitement attached to the information coming through neuron A, it passes through the tube or the axon, gets to the dendritic end or the bulb, and the communication happens via neurotransmitters, and now neuron B has received the information, it goes through its synapses, and it gets to the end of its neuron by traveling down the tube, and the information has been processed from A to B. Verizon Wireless can now bill you, right? That's where we are so far. The message that gets sent down and received by neuron B, if it's exciting enough, important enough, or novel enough, it can probably stimulate the learning process. The reason I say probably is because there's two very, very important prerequisites to this happening. One being total body, but more cerebrum-based glucose metabolism, being efficient with proper fates and no things going awkwardly wrong. Second, and potentially a bit more important, is a category of proteins called DNFs. These are derived nootropic factors, and they're the protein-based need that attaches after a neuron has gotten hot enough to make the change related to learning ensue on the second half, which is really what we're talking about today. Now, these DNFs typically come with a letter beforehand. It's usually going to be B or G, and this does nothing more than describe where it's coming from. If you see a B, that tells you that a specific cortical area, maybe it was your auditory or your lingual or your motor and your cerebellum, whatever it may be, one of those areas produced the protein on their own because the message was important enough and now learning can ensue. If you see it happened with a G, then that means a glial cell did it. Glia are about 80% of the composition of the brain, and they're cells purely dedicated to restoring the other 20%, which are the neurons that we talk about in reference. Now, once those two things are taken care of and the message was intense enough, we have long-term potentiation starting. This is the sword getting hot and the potential for it to be molded. Just because long-term potentiation begins doesn't mean learning is happening. The sword has only gotten hot, but nothing has changed. Now, what changes it is the actual hammering of it and the cooling of those small changes in the hammering. And it is a perfect analogy for how we actually learn, which is going through recruitment and refinement periods. So, long-term potentiation ensues, it's hot enough, and the change in the neuron begins. The change is going to be subsequently based on the information itself. Obviously, we adapt to the stressors and things that happen to us in life. It's not random. The way it changes and all that related to the stress is ultimately going to dictate how the neuron changes next. It's either going to recruit more or refine more. It doesn't matter what necessarily happens first, although it's typically recruitment. Because the next one will inevitably come. There are like peaks and valleys and all of those things related to like waves. One polarized end has to demand another one in the superimposed or opposite. That's how life works, right? Or it seems that's how the universe works. So as these recruitment and refinement periods happen and get longer and longer in their bandwidth, that is you actually learning something better and better. And remember, this is connotation free. So if you don't want to drink too much coffee, but you think it's a good idea in, those vague little moments, if you watch the morality and decision making video when you're under the influence of dopamine and you do it enough over the course of a month, 2 months, 3 months, even though you don't want to be attached to it, you don't want to identify it with it and deal with it, you've still taught yourself that caffeine is now a part of your lifestyle. And that can apply to many, many other things.